Tom Campbell here. I and MBT Events hope you like this video. If you find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. It would be very much appreciated. The links are in the description below. Thank you.
Good afternoon, Tom. We have some exciting news. There are two possibilities of two new paradoxes that your MBT theory solves. One of them involves the concept or the theory of intelligent design, which Stephen C. Meyer discusses a lot and has proposed. The other is languages and consciousness. And it occurred to you that these two paradoxes can be also solved by MBT theory. You've always spoken of the hard problems of physics, the paradoxes in physics that your MBT theory explains. And these, because of questions people have asked and because of things you've read and thoughts that have come up, you found two new ones, which is pretty exciting. The first one is what is called the Cambrian explosion, a period in history where everything started to evolve more quickly. Could you explain how you've come up with solving this other paradox?
Well, you're quite right, Donna. I try to find paradoxes, to look for them. You know, that's how you test theories. If you have a theory, then you want to see whether it'll explain everything. So if it'll explain the things that we know are true, but we don't know how to explain them, well, then that's good if your model can explain something that nobody else can explain. So I do that. I have my eyes and ears open all the time for people to point out paradoxes in their field. And I've run across these two, and they're even somewhat related to each other. I had a conversation, actually it was an interview I had with a gentleman who also had an interest in linguistics, the beginnings of language. And he pointed out to me that there was a paradox in where does language come from? Why do humans, it seems to be, why do humans so easily create languages? I mean, everywhere that you found an isolated bunch of humans, you find another language. On the other side of the mountain, they speak another language. And on that island, they speak another language. So it seems to me that that would make it sound easy for humans to create language, because any bunch of humans, separated from other humans, are going to create their own language. So that says language is an easy thing to create. Well, on the other hand, there's no other creatures that have created language like humans, although there's lots of creatures who have the ability to make a very wide range of sounds. They could create a detailed language, but instead, most critters have a very, what we would call kind of like, grunts and gestures language, which is kind of the bottom rung of language, is that you have some birds, or animals, they have growls and tweets and whistles and howls and all kinds of things that mean different things, but that's kind of at the level of grunts and gestures. It's not as varied and as detailed and as specific as what we think of as language. Now, every group of humans didn't necessarily have written language. Evidently, written language is a little harder. So everyone didn't have a written language, but everyone had their own language, it seems. So the paradox is that what seems to be so easy for humans seems to be so hard for everybody else. Why don't dogs and cats and monkeys and parrots? We know parrots can speak. I had a parrot, and the parrot would talk to Pamela in my voice, and would talk to me in her voice. Tom, and it sounded exactly like Pamela. I guess it was just having fun with us, but it could do that very well. So it had the equipment to make all the sounds that people make, and probably a lot more than people make, because, parrots can sound like cell phones ringing and all kinds of things they can do that people can't do. So they're actually more gifted in their ability to make sounds than we are. But yet, I'm sure they have squawks that mean things and cries and whatever. But again, that's the grunts and gestures level of language, not like people. So it's not just that they don't have the tongue and the mouth and the vocal cords for it, because some of them do. Obviously, chimpanzees and other monkeys, they have vocal cords and mouths and tongues that are very much like ours. But yet they're still kind of at the grunts and gestures level of communication. So why is that? That it seems so hard for everybody else, but easy for us? Well, there's a couple of reasons for that. And before I get to those reasons, I'd like to point out there's another thing that seems to be easy for us and hard for all the other animals, and that is a consciousness with a large decision space, a consciousness with the fine-grained detail that we have, the thinking that we do. Now we know that other animals think and have emotions, and they have a future and a past and a present. They're aware in all of those things. They know, based on past experiences, they know what's going to happen next. If you pick up their leash and walk toward the door, they can figure that out. So we know they're aware and have all the same senses of present, past, and future that we do, but they don't process data like we do. They don't think as much or as in much detail, just like the language. Grunts and gestures is kind of the low level of language, and what they do with their minds is kind of the low level of thinking. So you compare it to humans. So what makes humans so special? They seem to be different than all the other animals. And I got to thinking about that and the IUOCs that the larger conscious system created and why it created them. So if you recall the MBT theory, you have a larger consciousness system that's a monolithic thing, needs to have more states to grow into, so that it has a larger decision space and a larger set of possibilities in which it could evolve into. So it creates subsets of itself, gives them free will, and we call those the IUOCs. And the very first virtual reality was when the larger conscious system created communication protocols for these IUOCs so that they could communicate with each other in the big chat room, which is a metaphor for a bunch of individuated units of consciousness communicating with the LCS and with each other in this big chat room. Well, you can't chat until you have communication protocols or language. So you get language there so that you can communicate. And the LCS gave those IUOCs language so that they could talk, because after all, he created those IUOCs to be interactive, not just to sit there and do grunts and gestures at each other, but to be interactive, because that creates more possibilities if you have things that are interactive. So our language was really a gift from the LCS right in the beginning when it created us so that we could communicate. I'm not going to go over all the MBT theory, but everybody listening to this, if you don't have that, you're going to have to catch up and go listen to a video that talks about MBT theory. But for those of you, most of you who are already aware of that, that we had the virtual reality that is our physical universe was started from a set of initial conditions, right, and a rule set. And then you hit the run button and you let it evolve, and it evolves however it does. Okay, well, the idea was to create a virtual reality with avatars that the IUOCs, individuated units of consciousness, could log on to, such that the the IUOCs then would have a much broader range of experience, because this virtual reality had a whole lot of things going on in it that weren't in the chat room, because it was a physical reality, there was life and death choices, every day, and choices that were very meaningful and very significant and challenging, which is what the IUOCs were lacking in the big chat room. They had very little challenge. So they had lots and lots of potential, but they weren't developing that potential very much. It was just potential. They needed more challenge, more things that would get them out there thinking and learning and doing differently. So he creates this virtual reality. And as it turns out, creating a virtual reality is not that easy. You let it evolve, you got a good rule set and initial conditions that keep it stable, but just long and stable isn't the only thing the system wants. That's not its primary goal. Its primary goal is to develop an avatar, that has the experience in its virtual reality that would be valuable for the IUOCs to log on to and live that experience. And I suspect that the LCS had to tweak that simulation a little bit here and there to get what he wanted, or she wanted. And I suspect that's true because I know when we do simulations like that, and there's any number of those going on, where initial conditions in a rule set, and you let something go and see how it evolves. But if you want something specific out of it, then you're going to have to tweak it to get that specific thing out of it some. At least that's the way it usually works out. Because just stable doesn't necessarily go anywhere very quickly. That's very interesting. So, how much the system may have tweaked in order to come up with Homo sapiens and the other hominids that walked around about 200,000 years ago, I don't know. It's hard to say, but obviously some tweaking was done to create that potential. Okay, now, so we have all these hominids. Homo sapiens is one of them. Homo sapiens eventually outbreeds all the others and becomes dominant and really just subsumes the others. That's why we all have a little bit of Neanderthal in us, because the humans reproduced so much more quickly that we just kind of welcomed them on into the humanid tribe and eventually overwhelmed them genetically. So we have a little bit of that in us, but it's just a tiny little bit because we diluted their genetic material to the point that we spread it around to so many more individuals. So now we have people, and these people produce language. Now that's the first paradox. Okay, how is it that we get language? Well, we were able to develop language because the players of these avatars, right? The players are the ones that do all the thinking, make all the choices, right? Have the emotions and the feelings. It's the player. The avatar is just a computer image for us to look at so we can see what's going on the game board. Well, the IUOCs that were the players of these humanoids all had language. They'd been in a chat room. They'd been given language. So they already had the concept of language in their minds, given to them by the LCS. All they had to do was take that concept and actualize it in terms of the virtual reality. Okay, they make choices for their avatar. So now these avatars who all had experience with language needed to figure out how can we reconstitute that language we had here? Well, the biggest hill to get over in language is just the idea of it, just the possibility of it, the idea of it. That's the big part, coming up with that. The actual structural pieces of it, apple. We say apple and everybody goes, ugh, apple, and then you add one new word every day and, 10,000 years later, you got a language. So the mechanics of it aren't that hard to understand. It would just take a group of individuals who were trying to develop their language back that they had as consciousness. So it seemed natural to them to say, oh, what do we want to call this? And develop that language again. So they had the concept of it. See, that's the hard part. The easy part is doing the mechanics of naming objects and everybody learning that name, and that's the simple part. But the concept of language came from where? Who figured that out, that we could make all these sounds and that they would mean something? And, well, they already knew that. The IUOCs playing these hominids, avatars, already had the concept of language. So that's why it was easy for us. That's why any bunch of humans that got landlocked or on an island someplace, we could come up with our own language because we had the concept of it. So that's kind of the reason that explains, one, why it was easy for us, because we were in the chat room. Now, what about all the other things that weren't in the chat room? What about all the dogs and cats and the horses and the bumblebees? Well, the LCS was trying to develop this virtual reality for its IUOCs to play in. So the humanoid, the eventually Homo sapiens, was really the product that the LCS was trying to create. That was the main product. But the rule set and the initial conditions spun off all kinds of things. There were other things that developed as well, right? Plants and bushes and frogs and toads and fish and all sorts of things evolved out of that rule set. Okay, but they evolved very slowly out of that rule set. And that really wasn't what the LCS had in mind for avatars, with the fish and the frogs. They had some potential, but not enough potential. So what would it do then? It could play all the parts. It started this virtual reality by playing all the parts until the virtual reality developed enough that there were, clear parts and a clear number of avatars for the IUOCs to play. And then it said, okay, guys, okay, IUOCs, I've got a whole lot of avatars here for you to play. Go log on. This is going to be the fast track in evolution here. So meanwhile, you have the bumblebees and the clams and the foxes and dogs and cats or whatever, horses, whatever happened to be around at that time, or whatever the predecessors of those things were. But that's not what the LCS was doing. So it could have just played that part on its own and continued to play those parts, like NPCs, continue to play those parts. Or it could be that it took a little bit of its consciousness, not enough to make an IUOC, but just enough to animate a bumblebee or a frog or a fish to do the things that frogs and fishes had to do, so that frogs and fishes could also make choices and learn that to grow, and that there's good choices and bad choices. But that would have been just kind of an extra. That wasn't the main reason for developing the virtual reality. So it could have left them as non-player characters and just let the system play all those minor roles, or it could take a little piece of consciousness that doesn't have the same capacity or the same abilities, and let that be in different animals according to what they do, according to the choices that they had in life, according to a decision space that would be natural for them. So either one of those things then happens. So then we are special. It's not just that we're another animal that grew up here and just happened to grow up to what we are, but we were what the LCS needed in order to evolve its consciousness more thoroughly and more quickly, something that made choices. Now, let's plug all of these together. So you see, we have language that came with the IUOCs, and language allows us to think. We can't think much without language. If we take away language, our thinking is stuck down on that same base level as the grunts and gestures. We can think, but not very specifically, because we don't have any words for specific things. We just have words for big things like run, duck, good, bad. We have big concepts in our grunts and gestures, but we don't have, see the little yellow flower with the blue petals, and we don't have things to describe that kind of detail. But you can't think about that, or what do all those little things do, unless you can name them and discuss them. And it's not just a matter of making more nouns. It's a matter of being able to think about things in detail. Think about, how is this thing affected by other things? What's the purpose of this thing? How does this thing fit in, to the whole? What might I use this thing for? What are its properties? You see, the dogs and cats and horses don't have that sort of thinking process. Yes, they're aware, they have feelings, they have emotions, they have personalities, and they have crude language at the grunts and gestures level, but they don't think of things in that way because they don't have language.
Something was inserted, something was boosted at that particular time to allow for more evolution to take place. Is that what you're saying? Something.
Well, yes, and that was going to lead me into the next part of this.
Because it's an efficient system, and part of your theory is that it's very efficient, and whatever was happening was slow,
right?
Too slow.
Exactly.
And that's not good for an experiment, or it's not good for efficiency, right?
Right. Okay. So we have this larger consciousness system, and now it's got this idea, okay, of language, people, thinking, and because we have language, we can think in ways that are very particular and very specific, and we can create that language to give us whole lines of thought and inquiry, and suddenly our mental space blossoms because it has the language. The language came from the LCS. You see, the LCS always meant us to be the avatar of choice for the individuated units of consciousness. So you see how nicely that pulls together. All right, now, there's another aspect of this that kind of fits right in with this, and that is that I was listening to Stephen Meyer, and he was giving a little talk, and he said something surprising to me, and I said, oh, another paradox. And what he said was that it turns out Darwin was wrong. Darwin just wasn't right. Darwin said that the species evolves through a series of random mutations, right? So you have something, it mutates randomly, and you get something else. And if that something else is better at surviving and procreating, it continues. If that something else isn't good at that, then it goes away, becomes extinct. And that's the way the species come about. Well, everybody basically believes that up until recently. And recent evidence says that just doesn't work. That just can't work. And here's why. Now that we understand what goes into a cell, how cells create and how cells regenerate and create new cells, it's an immensely complex process. And the randomness in it is very large. So for a cell, to create the next cell, there has to be, like you have a choice of proteins, maybe there's 20 proteins, and if it picks this protein, it'll go that way. And if it picks that protein, something else happens. And so it's got choices like that. And then, of course, if you get multi-celled things, you have genetics, and there's lots of genetic variation. If it turns this gene on, it turns that gene off, it does this, it does this. And it turns out if you look at all of these kind of random things that could happen in a mutation, right? A mutation could be in any of these random events. Well, it turns out there are so many of these random events that cellular biology is so very complex and rife with random choices that, and this is astounding, this is what Stephen said. He says that we had this age called the Cambrian age, and you've probably heard of it referred to as the Cambrian explosion. And it wasn't because something like dynamite went off, but they called it the explosion because at that time in our history, suddenly there was this huge explosion of different life forms, different species. It's like you go into that Cambrian area and you got just, a few species, and you come out of it, you've got thousands more. And there just wasn't enough time for that to happen by random mutation. Random mutation takes a very, very long time because there are so many variables. We know that there's so many variables because here we have, almost 8 billion of us now, and no two of us look alike. No two of us think alike. No two of us are alike. Why? Because there's that much variation just, in who we are, how we develop physically. And if we had 100 billion of us, we still wouldn't be any two that were alike. There's plenty for the trillion and quadrillion. There's so many ways, all these variables. If you look at how many ways could a human be put together, well, it would be an astronomical number. And same for all the other creatures. Maybe all of them aren't as complex as humans, but same for all these creatures. So the number he gave, he said the probability. Now this is, probability gurus, I guess mathematicians or physicists or biologists who study probability, when they looked at all of the random choices that would have to be made for a random mutation, they said that to get all the species that suddenly occurred in this Cambrian explosion, the probability that could happen by random, by random events was 10 to the minus 70. That was the probability. That's a 1 with 70. That's a point. 0.000 with 70 zeros before you get to a 1. That's how low the probability is. 70 zeros set in front of a 1. Well, that is so improbable as to be practically called impossible. Probability that chance could have produced all those species is 10 to the minus 70. So in any case, that then led Stephen to the concept of there must be somebody who fiddled with that probability. It wasn't just random. It had to be non-random. Well, it only can be non-random if there is intelligence involved. If there's no intelligence involved, then that's random. But to make it non-random, that means put it in a specific way to create all of those things, then you need some kind of intelligent rearrangement of what's going on so as to create all those different species in that short amount of time. So that was the beginning of this idea that there was intelligence behind our evolution. Okay? What do we call that? Intelligent design? So right away, of course, the religious people said, well, of course, God did it. That's the intelligent design. And I think the religions jumped on that boat, but that's not really where that boat sailed from. It didn't sail out of religion. It sailed out of good science that said there obviously was some non-random thing going on, which means some effort that was focused on a particular outcome and worked. All right, now keep that in mind, and let me jump for a minute to a story about a moth, and then we'll come back to that. About 2 years ago, I had read an article again saying that there was a mystery, a paradox in evolutionary biology, because a moth that had come to Britain on a ship this was probably back in the 1800s or earlier, this moth came in a ship, and the moth was pure white, a white moth. And it bred in London, and within a short period of time, and I don't know how short that was, maybe 20 years, 50 years, 100 years, I don't know. But as far as species changing, it was a very short amount of time. That moth turned into a black moth. And this is the same argument. They said, that's impossible. Because if you look at the genes and the chromosomes and all the things that make a moth reproduce, and all of the probability that goes on and the randomness that goes on, it would have had to randomly pick different patterns, different colors, different shapes of things on its wings, and to go through all that randomly until it finally ended up with something black that would merge into the very dark, coal smoke of the early industrial age London city. That dark environment would have taken it 10,000 years or something. But this was much shorter than that. It was so short that the evolutionary biologist said, that's impossible. This is a paradox. We don't know how that moth figured out how to turn black that fast. Okay. Well, see, that's the same sort of thing, right, as the Cambrian explosion, how all those species happened to develop that fast. So it's the same problem, just in a single species or in lots of species. And at the time, I thought, oh, good. And I even said this in a couple of my talks, and then I kind of forgot about it and let it go, is that, well, a moth is conscious. A moth has an intent. And how does that moth turn black? It has an intent that it needs to find a place to hide. It needs safety. It needs to be hidden. It's afraid of being eaten. And that intention then modifies how its biology works. Remember, mind leads, body follows. A focused intent modifies future probability. So the probability isn't random. That moth has to go through red, yellow, green, purple, chartreuse, pink. It has to go through every possibility and every pattern of every possibility of every color that's possible before it runs and just randomly happens to hit on black, solid black. Okay, well, that would have taken, like I say, tens of thousands, if not hundreds of thousands, if not millions of years, but it happened very, very quickly. Well, because it wasn't random. That moth's intent modified future probability, and instead of being random, those probabilities were pushed up that would give it some sort of protection. Those got higher, and the ones that wouldn't got lower because of its intent. Well, it's this, and I had that, and that made sense to me at the time, and I didn't think about it a whole lot. And I think a couple of places, maybe when I was in Gonzaga University. Yeah. I think I mentioned that there, but I kind of let it go. But then when I heard recently about this Cambrian explosion, I thought, whoa, it's the same thing. We got all these species, not because they thought they wanted to grow up into more species, like the moth needed something, right? So it had its intent. But I thought there is where this rule that future probability depends on intent came from. You see, we know that it works that way. From my own research, my own ability to heal with my mind, to do things, I know that intent modifies future probability. And I always thought that was just because the system needed to give us some feedback, because the good schoolhouse needs feedback. So that's the feedback. We get to be part of the creation. We help design, if it is, with our intentions, what happens, what the future is.
Are you saying that intent wasn't always there?
Yes.
At what point did you postulate that intent came into the game?
Well, you see, at that point, it's not like the moth had intent, so the moth could turn black more quickly. But in this Cambrian explosion, that wasn't the case. You didn't have a moth yet. there were whole new species, you see, that were developed. And then it occurred to me why the LCS made the rule that intent modified future probability. Now, it is a good rule, and it does give us feedback, and it does put right in our face what it is we deserve, because we create that reality because of our intent. But besides that, what happened was the LCS had this rule set and this initial conditions, and they were chugging along, and it did work randomly. And in the beginning, that was slow. I mean, in the beginning, you just have this tight ball of high pressure gas, that's expanding. Well, waiting for that to turn into suns and planets and, oceans and things like that, that was a long time. So in the beginning, the system wanted to speed that up. So it said, we don't have to go in little tiny time increments. Let's take great big steps in time increments to go through this place, this early part of the universe, when everything is just probability. There's nothing going on other than just probability working with the rule set, right? Everything is just, you can calculate it all that way. There's nothing there yet. So at that time, it could have easily said, well, every delta t is a century. Every delta t is a century. The next delta t, another century, another 100 years, another delta t, another 100 years. And it could start cranking through that early part of the universe, which was boring because there wasn't any avatars. It wasn't getting what it wanted. It was just waiting until the system could evolve enough to produce what it wanted. So let's speed that up. So we have this very fast, every delta t is a century. Now, I just made that up, maybe every delta t is a millennia. But you get the point. The idea is the delta t was very big, so we could get through that mostly just probabilistic beginning. We could get through that very quickly, and it didn't matter whether the probability was just right or not. It didn't matter whether a sun coalesced here or over there or someplace else. They just throw them out, make them. Probability was good enough. You didn't have to have details at that point. So physicists call that the inflation at the beginning. They say that our world, as it evolved, there was this big inflation where it evolved very, very quickly, and then it slowed down. Well, that's why they went very, very quickly. So there's another paradox, I guess. Why did that inflation happen? Another paradox is, well, because that part of the simulation was boring and didn't do what the system wanted, which was to provide an avatar for its IUOCs. So it got through it in a hurry by having a huge delta t. And it went very fast through that period. All right, now it kept chugging along until things got more detailed. Okay, it did have planets and seas and oceans and jellyfish and things. It had some things in it. So it probably slowed down and wasn't leaping, millennia at a time. It had to slow down because now there were details forming, not just big, massive things, but the details were forming. Cells were forming, making different critters, and that needed a lot smaller delta t, to keep up with that kind of thing. So then it slowed down, but it went on and on and on. And because it was so hard for a complex being to randomly mutate into something more useful, the system's going like, we're never going to get to my avatar that I need for these IUOCs. It's going to take so long. This randomness thing just is too inefficient. It's not getting me where I want to go in time. And then the system says, if randomness is a problem, how can we make it not random, but still tie it in organically to the evolution of the system? You see, you don't want to say, well, I'll just tell it what the answer is. I'm going to make up a being and I'll call him a human being and we'll just poof him out of nowhere. And, he won't really be organic to the earth. It'll just be like something that, an alien dropped off there one day on their spaceship. It won't be part of the earth. So it had to be still organic to the system, but not random, because random's just going to take too long. So at that point is when the system said, we're going to let their intentions modify future probability. So if you're a white moth and need to be a black moth, it won't take 10 million years to get there. That's too long. It's inefficient. You'll get there in 20 years or 100 years or whatever. It'll be much, but the same process will happen. It's just that it will happen in a non-random way, driven by the needs of the individual critter, their intentions, their needs. So that's where I think this rule of focused intent modifies future probability, that's when this rule was put into place. It wasn't put into place just to give us feedback. It was put into place because otherwise the system would still be waiting for something of use to be developed as an avatar. And it wanted to speed that process up. And then I guess when it thought about it a little bit, it said, oh, that really works well because now we're giving them feedback. And now, they will have a hand in the creation of what they create will be partly theirs. And that's even better. So I guess that's like, buy one, get one free. It solved a problem plus solved actually another problem unintentionally.
That's really fascinating how all of the creatures would use their intention to survive and to develop whatever it is they needed, like camouflage, animals that have natural camouflage, all of those kinds of things that was developed because they had that ability to modify, self-modify with their intent. That is so fascinating.
Right. So now we have this genetics, this very complicated, really digital information that tells our cells how to reproduce, how to make another copy of ourselves. And that then doesn't work just randomly either. That works with intent. Now, there's another. So this is what we've already gotten 3 paradoxes here. So now that's another paradox, which is how is it that Bruce Lipton's biology works, called epigenetics, that you can actually change your genetic structure, what your genes are doing with your intent. Again, mind leads, body follows. Now, there's some fixed things in genetics that are harder to change, but it's the details, the things that have more uncertainty in them. You see, that we can change that probability where there's more uncertainty. We've talked about that before. Where there's lots of uncertainty, then there's more room for intent modifying those probabilities. When the uncertainty is very small, then it's hard to change those with intent or anything else because there's very little uncertainty. The probabilities are very strong. So in those areas where there was more uncertainty, well, which was what the epigenetics is all about. It's in those parts of the genetic code that are easily changeable, that intent changes them. So you're not stuck with genetics. Don't think of your genetics as I got this genetics and I just have to suffer through it. This is my lot in life. I'm this, I'm that, and I can never change it. Well, some things are hard to change very much, but it's surprising what we can change with our intent. And particularly when we're very small. When you're very small and you're growing and you still have a lot of changes you're going through, well, now there's a lot more room for your intent to make those changes because there's more uncertainty in what you're going to become. And the same with the parent putting energy into a child, becoming a certain way, or the child saying, when I grow up, I'm going to have blonde hair. When I grow up, I'm going to have blue eyes. And if you put enough effort into that, well, that's one of those things that may be hard to change when you're an adult. If you say, oh, I want my eyes to change from brown to blue, well, good luck with that. That's not likely to happen because that probability is very, very small. At this point, you're an adult. Probability of that changing is very, very small. But there's things that can change, things that can turn on and off and whatever. And those things are very readily modified with your intent. So that's what Bruce Lipton's work is all about. So that's another paradox. So we're piling now. That's the fourth paradox we've piled on.
We started with 2 and now we have 4. This is it's developing.
So that's another paradox that's been solved. So see, isn't that interesting?
Yeah.
That you kind of said, okay, the system did tell us that our intent would modify future probability. I know that because I've done thousands of experiments. I just know that's a fact. And I just think, well, okay, it just gave us that because we needed feedback. But now I see it gave us that because it had to. It wasn't a kind gesture on its part to make our learning more efficient. It was necessary for the system to produce the avatars that it needed. Otherwise, it would be waiting for another couple of, 10 to the 7th? How many billion is that? You know, that's like billion, 8 of those. 8 of those billions in a row to get that much. So yeah, I think that was very interesting because it all falls together, you know. The system, it's not that you can explain, you know, that intent modifies future probability. Okay, I can show that it does, but it's different. It's more powerful to say the system had to do that. It's not that it just did that, but it was something that was necessary. Well, it was logically required by the system to do that. It had to. Otherwise, it'd still be sitting, you know, waiting for this virtual reality to produce something useful. So it needed to do that. And then that's a stronger argument than just that, well, for some reason it did that. I know because I can, you know, do these experiments and show that, but to show the basis for it, well, that's the basis for it. We see this in this Cambrian explosion, that something changed. Something didn't work the way it did before that. You know, we get to that point and the rules changed. And it's impossible for that to have been done by random events.
You're always looking for new paradoxes to plug into your MBT theory.
Right.
And here you have 2, now 4, that are logically explainable within a science framework, but also open to other interpretations, I guess, as well.
Yeah, how is it that humans think differently than all the other animals? None of the other animals think like humans think. They don't think in that consistent detail. They don't have that intellectual thing going on. They can't do that very well, but why not? Why didn't they evolve that way too? Well, you know, and why is it that humans seem to find creating language so easy when it's so hard? Well, see, it's another one. And yeah, it's interesting that I look for these paradoxes, and so far I found dozens and dozens and dozens of them all over. I found a bunch of them in physics, but they're popping up all over the place. And so far, 100% of the time, the MBT, you know, theory model has a really tight explanation for them. Not only that they could happen, but that they must happen. That they have to happen, that they're logically necessary for the model to work. So I think that's kind of neat. And, you know, I will go on looking for, you know, new paradoxes, but the paradoxes have to be paradoxes that are very fundamental, you know, to the nature of reality is what I'm talking about. Not a paradox, you know, why does Joe eat 5 eggs every morning? You know, that kind of a paradox is not what I'm talking about. I'm talking about big picture, fundamental things going on that we know they are like that, but we don't know why they have to be like that.
I think you've very clearly explained how and why they have to be that way. And it's absolutely fascinating. This is something new, and we'll have to continue on with discovering some more paradoxes that your MBT theory can solve. Very interesting.
Yes. Well, it's been fun. You know, we think because we have language. We have language because we were in a chat room. We were in a chat room because the LCS created us to interact with him and with others. And, you know, so on. It's just the logical consequences just keep spilling out. The one computer that Google created, that the Google employee said was conscious, or he thought it was conscious. Remember, we talked about that. That computer was a language computer. So what they had done is use neural networks, but to teach that computer the meaning of language so that it could go out on the internet and read stuff or listen to things and actually understand what was being said because of language. So that's the kind of computer it was. It wasn't just some neural network they sent out to the internet. It was one that was designed to process language. It was their advanced language processor. So it would be something that if you spoke to it, it could actually understand what you were saying. I think that's the idea they were, again, your handy dandy butler robot going to have to understand, what you tell it. And so they were creating this software that could understand natural language. And that's the computer that appeared to become conscious. Of course, computers become conscious not because the computer becomes conscious, but because the LCS has an IUOC log on to that computer to be its consciousness. But see, the language was what was important to let that computer be conscious. It needed ways to think. Feelings have to be expressed. And if you can express a feeling in words, then that feeling's real to you. Otherwise, you just have it. It just happens to you, but you can't, if you can't express it in words, then it's just a thing that happens and goes away, and you can't think about it, where it came from, much about it. You can't think of it. It just happens. So in order to reflect back and think on things, what caused that? Where did that come from? How does that fit in? That requires language to do that. So that was a language computer. And that's why it was able to become conscious, is because it was a language computer, not just because it was a very clever bunch of neural networks.
But their definition of conscious computer is different than consciousness logging on.
Right. They think they're going to build consciousness, but you don't build consciousness. You build a platform in which consciousness can interact. But consciousness needs to think. If it doesn't think, then it doesn't act. It's not conscious. Consciousness is a thinking thing, right? And it's an awareness thing. The awareness requires language to describe what it is you're aware of. Oh, I'm aware of this. And what does that mean? Oh, that means, this, this, and that. And how does that fit into my reality? Well, you have to have all that's all thinking. Otherwise, it's just there. And you can't process anything about it. It's just there, which is the way most of the things are for animals. Things are just there or not there. They see things in very basic ways, but they don't do a lot of logical thinking or even illogical thinking. They don't do a lot of thinking. Now, some do. My dog does. I have a dog that can think pretty well, maybe about the same as a 2 or 3 year old sometimes. But and that's kind of amazing. But most dogs don't even achieve that.
Argus? Yeah.
Yeah.
Yeah. Yes.
Yeah, he's a smart guy, and I know of other. He's not the only one. There's lots of dogs that are very smart in many ways. They show that they obviously are thinking, but they tend to think in a limited space. Their decision space is rather small compared to humans' decision space. And our thinking gives us a huge decision space. Without decision space, then your free will isn't able to do much. So this concept of decision space is a very important concept. You get more decision space with language. Language allows you then to think and make more choices. You see, that's important. And then when you make all these choices and you can modify future probability, now you start creating a future that looks like you, or it looks like what you want.
Interesting. It's all been fascinating, Tom. Thank you very much.
You're welcome, Donna. Well, it's been fun.
It's yeah, wow.
I and MBT Events hope you liked this video. We will continue to post videos for free on my YouTube channel, but please understand, these videos are expensive to produce. They represent many thousands of hours of production and editing as well as all the necessary audiovisual equipment, computers, and software. If you find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. It would be very much appreciated. The links are in the description below. Thank you.